everyone! Chapter 2, Learning Target 5. It's getting a little bit silly in here. This is Miss Oshier.
And Miss LaHart.
And we're talking about asymptotes.
Asymptote. What is an asymptote?
It is not a swear word. It is a mathematical thing. So don't ever call me an asymptote because it's not very nice.
Right. There's a bunch of math jokes online. Look them up. They're funny.
They are funny. So an asymptote is almost like a barrier. Mm-hmm. It's something that a graph can never cross or touch.
But it'll approach it. It'll look like it's going to do it, but it won't do it.
But it won't. Okay, so it's always shown as a dotted line.
Yep.
And it's like, oh, it's going to get really, really, really close, but not actually ever touch it.
Mm-hmm.
Really, really close. It's like that I'm not touching you game.
Ooh.
You'll never touch.
That's funny. I hate that game.
Me too.
You can have horizontal asymptotes, vertical asymptotes, and oblique asymptotes. That's just the shape of what they look like.
We'll call them slant asymptotes. Basically, they're not, oblique is not vertical or horizontal.
Slanting, whatever.
So a vertical asymptote will occur at the excluded values of x. So you already know how to find vertical asymptotes. You've been doing it for a while. You just didn't even know you were doing it.
Whoa.
So you factor that bad boy. Nothing crosses out. And then you have your excluded values of 2 and negative 3. Hey, guess what? Those are your vertical asymptotes. 2
What?
and negative 3. Whoa. Mind blown.
So those undefined values are what your asymptotes are. So now we have to know, like, as you're approaching it from the left of your graph or from the right, is it going to positive infinity or is it going down to negative infinity?
Now, we know that you have graphing calculators, but we just want to show you the process of this because this is something that comes into play during calculus. We want to make sure that we cover it for you.
Mm-hmm.
So basically, you would substitute this value in. If you have a number to the left of 2, so just a little bit left of 2, that would be a negative up here, because we don't care where the number is. It would be a positive down here, and it would be a negative down here. A negative over a negative is a positive, et cetera, et cetera, et cetera. So that's where all of these numbers are coming from, these negative, positive symbols. We're just plugging them in and saying, okay,
What
about what
sign would it be?
Exactly.
So then once you evaluate, if it goes to positive, that means it's going to positive infinity. Now look at this notation. F of x, arrow pointing to infinity. That just means f of x approaches infinity. That's the fancy word for it.
Okay, and then you could have a little minus sign for the left and a plus sign for the right. Again, we just wanted to show you that. We're not going to test you on this because it does come into play in calculus. Okay, so verbally versus symbolically, this is how it would look. F of x approaches infinity as x approaches 2 from the left.
So that's the math behind it.
F of x approaches negative infinity. That should be a negative sign, my bad. As x approaches 2 from the right.
Okay.
Etc., etc. You guys can read.
And pause if you need to. But basically, that's the math behind the notation. That's what we'll be kind of looking for.
Okay, so this is what it tells you. This is what we were trying to talk about. Like, it approaches negative infinity, it approaches positive infinity. It's just letting you know what the function is doing as it gets close to that asymptote. We're going to be sketching it, so you're going to be, using
you're going to be in on
skills,
this.
But we just, again, wanted to point it out because the questions will come up a lot in calculus. Horizontal asymptotes. So these are going to happen when a completely reduced rational function has a denominator degree greater than or equal to the degree of the numerator. Blah, 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 blah. Let's just focus on the fact that there can only be one horizontal asymptote or none. You can never have more than one.
One or none?
One or none. That's it. Okay? And a graph can intersect a horizontal asymptote technically, but not a vertical asymptote. So I know that we said an asymptote, like it never touches. Horizontal ones are kind of special.
They have other issues going on.
Yes.
This beautiful chart.
You need to know this.
You need to know this chart. Because
it looks scary, but it's not bad. Okay, if you have the degree of the denominator, so we call this small over big. If the degree is smaller on top and bigger on the bottom, your horizontal asymptote is always y equals 0. If your degree on the top is bigger than the degree on the bottom, this should say equal, I'm sorry. Oh, see, I was trying to point something out and I forgot about it. If they're equal, so see how I see a 3 and a 2? Remember, you go to the leading coefficient, go to the highest degree. There it is. So 3 and 3. So you have the same. You do leading coefficient over leading coefficient. So this would be 1 over negative 4. That's where this comes from.
Okay, so if they're the same, you just use the leading coefficients. And if you have a degree of denominator less than a degree of the degree of the numerator, then it's no horizontal asymptote. So big over small is okay. No
big
horizontal.
Big over small is a no.
Okay.
Okay. So examples. I have small over big, so it's going to be y equals 0.
See? That's how easy it is.
That was easy.
B, I got B. Okay, so I got 2 and 2, so they're the same. So I have to use the coefficients. So 4 over negative 2 gives me negative 2. Y equals negative 2. That took me a minute. I got there.
Whoa. In C, it's a third degree over a first degree, so that's a big old no.
And that's how you do that.
Yeah. Okay, slant asymptotes.
Oh, boy.
Now, these occur when the big over small situation is happening. Okay, so when there's no horizontal asymptote, there could be a slant asymptote.
Right.
So first thing that needs to check is it's big over small. Second thing that needs to check is they have to have a difference of 1. So like a 2 over a 1, a 3 over a 2.
Right.
A 4 over a 2 would not work. There would be no slant asymptote either.
Okay. So then all you got to do is long divide.
Or synthetically divide, whatever makes more sense. Okay. So we put the positive 1 over, and we put all of our coefficients, and we don't care what the remainder is. We just are getting it down to this linear expression. So 2x plus 5. That would be your slant asymptote.
Boom. Boom. See?
That's it. Have a wonderful day. We'll see you in class.